Hello, everyone. My name is Kelly Roberts, and I am the creator and founder of a new online learning platform called Cracking the Code Academy. What our academy is attempting to do is fill that void between studying in your classroom and studying at home to make sure that students have targeted, focused test questions that they can use to help better prepare for the exam. What makes our learning platform much different than anything else that's out there in the market is that we are the only learning platform in the market that's designed to give students actual test taking questions. And we not only provide you those questions and the answers, we also tell you why that answer is the correct answer. And not through text, not through something else that you'll need to read, but through an actual video and live interactive sorts of material. So there will be some live content, there will be some recordings, but the point is that you are not going to have to read a wealth of information in order to get our content. So what it is that we're going to do today is that we're going to do a couple of things. One, we're going to talk about some of the hurdles there are to test taking and why students struggle with test taking in courses like anatomy and physiology and microbiology. We're also going to talk about our strategies to alleviate some of those issues that students have when taking these courses. And then we're going to have a sample lesson to give you a little bit of a taste on what it is that you're going to find and the kind of content that will be available to you at Cracking the Code Academy. Many of you all are here because of the recommendations from the YouTube page with our lectures, and those are continue to be available to you for free, but we also wanted to add on to what it is that you are using for your studying, and that's why we have created Cracking the Code Academy. So Cracking the Code is an online learning platform that is going to give you all learners the ability to feel much more confident when you're doing the worst part of the class for many students, and that is test taking. So we go over individual test questions, and we not only give you the correct answer, but we tell you why the correct answer is correct. So this formula has actually been created by people like myself, college professors who have years of experience. Myself alone, I have over 15 years of experience teaching anatomy and physiology at community colleges, at universities, from Chicago all the way down to St. Louis, Missouri. So we have a wealth of information, understanding, and resources on how to help you crack the code and become a phenomenal test taker. And that's really what it is that we're doing. So we're going to be offering test taking question courses for microbiology, human anatomy and physiology, as well as some introductory biology and human biology. So what we found was that many students are experiencing test anxiety. And if you're watching this video, you very likely may be one of those students. And what that test anxiety does, at least what it did for me, is that it really hampered my ability to concentrate and really recall information during an exam. The next issue that we saw was that students aren't always prepared. And when we say not always prepared, it's not that you didn't go over the information adequately. A lot of times it's how you went over the information, and part of that preparation only includes a handful of practice questions, and those are usually at the end of the chapter, or sometimes they're not even, the correct answer isn't even provided for you. So you're kind of learning in a silo of trying to understand what the correct answer is. So that's obviously going to lead to poor test performance. The next thing that our research found was that there is a little bit of a lack of reading comprehension. So difficulties understanding the question or misinterpreting the instructions as it relates to the question can give incorrect results. I've seen it time and time again with my students that once we go over the exam, that when I explain what the question is asking them, they'll say, oh, of course I knew that answer. It was just the way that it was worded. Or I forgot to read which of these is not a part of this particular system or process. So reading comprehension and taking that time to read is also an issue. These are all issues, by the way, that we're going to actually address in the Cracking the Code Academy. The next thing that we found was that there's what is considered to be poor time management. During exams, students many times spend way too much time on one question, and they really don't give themselves sufficient time to answer all of the questions. And that really becomes a problem if your exams are timed, which is the case for many online exams. They're going to be timed. Or it is the case when you're taking like the NCLEX, the MCAT, the DAT, any of those professional school acceptance sorts of examinations, that those a lot of times can lead to just not having enough time on there. And then the final thing that our research showed us was that there are a lot of external noise and factors, such as the temperature or personal issues that a student might be going through, that can really impede our ability to focus and concentrate on the test. So what Cracking the Code Academy is attempting to do is to alleviate. So what's the solution? That's where we come in with Cracking the Code Academy. We provide guided practice exam questions in each one of our courses. They're going to contain actual exam questions from a wealth of different resources based on the research that we've done and based on the years of experience that our professors and instructors at the Academy have. And we're going to give learners opportunities to not only see those exam questions, but also an opportunity to listen to why that correct answer is correct and how that we are able to come about to get to that correct answer. Why are we doing this? Well, the reason that we're doing this is because studies have shown, specifically we're citing a study that was done by the Human Anatomy and Physiology Society, HAPS, which is pretty much the leading society of anatomists and physiology professors in the entire country, that HAPS found that students who are able to have a practice exam scored higher than those students that didn't have the opportunity to take a practice exam. We also wanted to make sure that our content that's provided is going to offer time savings. None of our videos are longer than 30 minutes. It's going to be very short, very quick, and to the point to give students an opportunity to maximize their studying outside of the classroom. And finally, we're going to have targeted content. The content is always going to only be over one chapter or one concept type to make sure that you get the best bang for your buck. It's very important that the information that we cover for you is going to really focus on those most difficult exam questions. So we are unique. We are the first to the market. We are the only to the market that, to our knowledge, that has targeted exam content that is filling this gap between the classroom and your self-directed study. So of course you all are spending a lot of time with your textbooks and your notes and with tutoring services and your flashcards. And then of course you're going to class and you are listening to your professors, you're doing those flipped classroom activities, you're doing those homework assignments. We're here to fill that gap between the classroom and your self-directed study there. And in this gap here, we are able to provide content that is very unique in the sense that we're giving you actual exam questions and how those questions are correct and why they're correct. This platform, this process that we're using, our program, has actually been tested by thousands of different learners in various different industries over the past 15 years. So when we say various different industries, we're talking about different types of courses, both academic courses in the sciences, and we're also talking about training material for the corporate world. So these are when you graduate and you get into a corporate world, they still have training there a lot of times. And so we also develop content for commercial companies as well. So without further ado, let's spend a little bit of time, maybe 30 seconds or so, that's talking about here Bloom's taxonomy. Most of your exam questions are going to fall in one of these categories, whether it is asking a student or asking you to create something based on the information that you've learned, to evaluate a question based on information learned, to analyze the relationships between different concepts based on the information that you've learned, apply, understand, or remember. The further you get down this scale, the more that you're going to be able to see that they require less intensive thought processes. So remembering is at the very base. That just wants you to basically regurgitate information. Understanding means that you fully grasp the meaning of something. So things that will ask you to explain, paraphrase, report, describe, or summarize. Applying is where it's going to want you to use the existing knowledge you have coupled with what you've learned in that new content and able to put it in some different sorts of context and really apply that understanding to various different circumstances. So practice, calculate, implement, operate, use, illustrate, those are all kind of good words for this whole apply. As we start to analyze, we want to explore relationships between different cause and effects and various different concepts and how they connect. A lot of what we do in anatomy and physiology, especially the physiology portion of it, and in microbiology, pretty much all of your sciences, is that we want you to be able to take an organ system and be able to see how it fits with the other organ systems and how that really plays itself out. Evaluate, make judgments, and based on sound decisions, and then to actually develop your own content based on the information that you've learned. So for every exam question that we go over in the Cracking the Code Academy, specifically for the anatomy and physiology and the microbiology, neuroanatomy, intro biology, any of those sciences, we're going to have this Bloom's taxonomy so that students are able to understand exactly where on this hierarchy that particular exam question is going to fall in, and that's going to help students to be able to better understand how to go about tackling that question and what it's really asking you. So let's go through some sample questions here, right? So this is a question that's coming from the muscle unit. So the muscle tissue, as you will recall, if you've taken anatomy and physiology or you're currently taking it now, the muscle system is one of the organ systems by itself, and it consists of 3 different muscle types. You have smooth muscle, which is going to be lining cavities and lining organs. It's involuntary, it's non-striated. You're going to have skeletal muscle, which is kind of the muscle we all think about when we think about our muscles. We're thinking about those skeletal muscles often. And then you also have, and skeletal muscle is going to be voluntary, which means you're consciously thinking about it. I move my fingers. I am consciously thinking about moving those fingers. My stomach digesting my lunch. I am not consciously thinking about that. It does it on its own. Thank goodness I don't have to think about it. But skeletal muscle striated under your conscious control. And then the final muscle type is going to be cardiac muscle. So cardiac muscle is striated like skeletal muscle, but it's also not under your conscious control. You don't have to consciously think about telling your heart to beat to have that process happen. It kind of does it on its own. So these sample questions that we're going to run through in the last portion of this little video that we have here are going to give you some of the content and what Cracking the Code Academy looks like, and you can determine if this is something that you might be interested or something that could work for you and be a part of your arsenal of tools as you study. So first thing we want to point out here is that this is going to fall under the remembering. So this is just kind of regurgitating that information that you've already learned from your textbook. Another thing that I would like to point out is that this particular set of questions that we're going over is coming from the Martini and Nash Anatomy and Physiology textbook. So this is going to be the book that it is coming from. I don't know if you could see that very well, but I will link that in the description below. So, question. In a sarcomere, the central portion of the thick filaments are linked laterally by proteins of the what? The Z line, the M line, the H band, the A band, or the I band. So in this situation here, it's going to be requiring that you remember what a sarcomere is. And a sarcomere is a repeating unit of muscle. So I'm putting my little fingers here together because this is the end of a sarcomere and this is the beginning of a sarcomere. And if we move down the line, then this would be the next sarcomere and so forth. So this is what our sarcomere is, this little area here. Then we also want to visualize what other components go into a sarcomere, where we have our actin and our myosin filaments. So these are all things. It's not asking me to generate anything. It's not asking me to analyze anything. It's asking me to recall or remember this information. So I need to be visualizing that. So if we are visualizing that, and you could have this all drawn out, and that is actually what we recommend at Cracking the Code Academy, is that whenever it asks you any questions that it's going to require there is a diagram that you've learned in your textbook, draw that sucker out right there in your test. Ask your examiner if you can have a piece of scrap paper and be more than happy to, give it back when you're all done with it, but you want to make sure that you can draw this out. So what we have here, so this is a Z line. The Z lines are between the sarcomeres. So this is my sarcomere, this is a Z line, and this is a Z line over here. They're going to be between the sarcomeres. Then we had our thick filaments and we had our thin filaments in here. There's our thick filament, and then the thin filaments are on the outside of it. And then we remember that we had all of those different bands that we laid out. A lot of times when students have test anxiety, I was one of them, you have all this information in your head, but sometimes you kind of, it gets jumbled up because you're so nervous, you're so concerned with making sure that you make the right decision that you tell yourself, you freak yourself out and say, man, I don't remember. I don't exactly know what this is. But if you take your time, break it down, okay, what is a sarcomere? It's a repeating unit of contractile muscle. I remember that. I've studied it. It's on a flashcard. Let me draw this sarcomere out. So as you're drawing that sarcomere out, you label it in the way that you've been studying it. So now that we've got our sarcomere labeled, all we have to do really is look at it. And so it says here, the central portion of the thick filaments are linked laterally by proteins of the what? Well, that's right there in the middle of it. And that would be your M line. So that would be your correct answer there for that, which is your M line B. So next question we have here, this is going to kind of fall in that apply sort of genre. So we're moving up this scale just a little bit, Bloom's taxonomy. We're moving up that. So we're applying. Now we can still take that same sarcomere that we just drew because it's asking about muscle fiber contractions, and it's still asking about those different bands, those different zones of overlap, and all of that good, but whether their zones of overlap are increasing or decreasing, whether their A band is getting smaller or it's getting larger. So we want to make sure that we can still use, that we're analyzing and using all the content that we've already created for ourselves. So the question here says, when skeletal muscle fibers contract, well, we understand from our study, from our lectures, from our looking at animations, from our study partners, that when muscles contract, then that sort of thing is going to take place. So we're going to actually have things pulling in together this way. We know our myosin heads are going to be the ones that are pulling those thin filaments in towards that M line, that center line. So when that skeletal muscle fiber contracts, what I would do and what I recommend to my students to do is to write down all the things that happen when that skeletal muscle contracts. Do the zones of overlap get larger? Being that if this is a zone of overlap, this little area here, that zone of overlap, now it's greater zone of overlap. So we went from just having this little piece right here overlap to now we've got the whole finger overlaps. Is that happening? What's happening to the H bands? What's happening to the I bands? So when the skeletal muscle fibers contract, H bands and the I bands get larger, not so much. What we did write down was that those zones of overlap are actually getting, and we're going to highlight that or underline it, zones of overlap are getting larger. So that is the correct answer to that particular question there. And once again, we could draw this out. You can draw it out again. It's just the exact same image as we had before. You wouldn't have to draw it again a second time on your test, but you could have it to refer to. Next question, going back to remembering land over here. Heat energy gained from muscle contractions are released by what system here? So when you are hot and your muscles, they get hot, and if you're not doing this already, I want you to rub your hands together and see all that heat you're generating. That's that friction. Your muscles underneath your skin are also doing the same thing. They're generating all of this friction. And so when your muscle gets hot and we need to dissipate or release that heat from the system, where does it come out of? Does that heat come out through respirations? Are you exhaling it out? Now, we are breathing heavier because we want to make sure we're getting enough muscle or oxygen to those muscles that are doing this work. We're releasing more CO2 because we're exhaling all that good stuff off, but we're not really releasing heat. It's more of a gas exchange there. So that one doesn't really work for us. Cardiovascular system, that's more of an internal type of system that it doesn't really have any way to release heat per se in large quantities. Now, there is some release of heat from the cardiovascular system and you think about the terms of your blood vessels dilating. So the blood vessels will dilate. That's one of the reasons why you get a little flushed when you're working out and those muscles are contracting. Those blood vessels are going to have some dilation, and there will be variable amounts of heat that dissipate as a result of that. But it's all inside, like those blood vessels are all inside. So that doesn't really work as well because it's not a super efficient process, okay? So we're gonna squiggle that guy out. Urinary system, well, there are some products and excess fluids, some ions that we don't really need anymore. Those are going to be released, but not really addressing that heat. And the same thing with endocrine, that's looking more as a hormonal sort of issue. So it's not really releasing anything. Your skin, on the other hand, remember we talked about way back in a previous chapter, we talked about evaporative cooling and we talked about sensible perspiration and insensible perspiration. this is where all of that heat is going to be released. So that is a remembering thing. It's not asking you to draw or to use any other context clues in here. It just wants you to remember, how was this energy released? And these types of questions are usually word for word verbatim in your textbook. All right, let's move on to the next one here. Another remembering question. Which of the following types of muscle fibers are best adapted for prolonged contraction, such as standing all day long? So remember, this is going to be kind of a conversation about those fast twitch fibers and those slow twitch fibers on here. So it's a remembering because it's going to ask you, once again, this is probably a question that is verbatim, that is in your textbook when it compares and contrasts those slow twitch and those fast twitch fibers. So what I would recommend if I were taking this question, I would write down those different types of fibers that we talked about. What are all the attributes of a slow twitch fiber? What are all the attributes of a fast twitch fiber on there? I would kind of write that information down, have it in the little columns here on the side, and really make sure that I'm hitting all those bits. So in that kind of writing down of that information between comparing and contrasting fast and slow twitch fibers on here, even though this isn't an analyze or apply type of question, I'm going to make sure that I brain dump all of that on my paper so that I can have my resource right there and get it out of my head and something that I can look at. And then I will remember that, oh, it's those slow twitch fibers that are best adapted for prolonged contractions, such as standing all day long, because those fast twitch fibers are going to give you a powerful burst, but they're really built for power. They're not necessarily built for endurance. So they're going to be those slower twitch fibers that are at work here. So we want to grab slow twitch fibers is the correct answer to that. And what's beautiful about this and our program is that a lot of the questions here, even though they might not be word for word, they're very similar to the kinds of questions that you will take on this particular content in the muscle chapter. So let's go into another question. This kind of moves up the ladder, and we're here at the understand. Which of the following is not, and I have my students highlight, underline it, draw it out, a characteristic of smooth muscle? Now, just as we had between that slow twitch and that fast twitch fiber question, I would write down everything I know about smooth muscles. So I would talk about how, what the nucleus looks like, if there are striations on there or there are no striations on there. I would talk about how many nuclei they had, or if they didn't have any nuclei, just once again having a running list. Now keep in mind, this only works if you've done a little bit of studying on your own, which I know you all have done. So you already studied some of this material. Now what it is you want to do is make sure that you are giving yourself the best opportunity to really execute on your exams properly. So here, striations are due to the orderly arrangements of the actin and the myosins on here. So let's pause for that one. We have written down that smooth muscle is not striated, so there are no striations on there. And we know the striations are those little lines that we see when we look at the histology or a tissue of muscle, right? So this one is one of those questions that the first thing that you would say to yourself is that, well, you know what, that's true, right? Because striations are due to the orderly arrangement of actin and myosin. While that statement may be true, actin, those striations aren't on smooth muscle. We don't have those there. So we're going to put a dot by this guy and keep going because, like, that's something for us to consider, right? So then the neurons that innervate the smooth muscles are under involuntary control. Check. We know that's true because we are looking for which of these things is not. So that's true. Smooth muscle cells are uninucleated. That's true. Smooth muscle cells do not contain sarcomeres. That's true. Thin filaments of smooth muscle fibers are attached to dense bodies. That's true as well. That's all of that information that I would have written down in some form or another right over here on the side. What's not true is this part here. Why? Because there aren't any of the striations in our smooth muscle. So that's why that is the best answer for that one. All right, so I really hope you enjoyed this very quick preview that we have here. There in the Cracking the Code Academy for the muscle tissue, we have many, many more questions that we'll go over, and we actually spend the entire time looking at each one of those questions and diving in even deeper than we've done on this video here on why that correct answer is correct and how to really minimize, if not mitigate, any of those test taking anxieties and risk and all of those pitfalls that we have seen students fall into for decades in teaching here. So I hope you give us a try. Come check us out at Cracking the Code Academy, and the link will be in the description below. Thank you, and I hope you're having an amazing afternoon, morning, or good night. Bye for now. See you at Cracking the Code Academy.